Hurrah. Okay. So I thought we'd start off with an overview of the architecture of the Wave in a Box software, which is, of course, the sort of the main goal of the Wave team for this year is to produce Wave in a Box as a working, federatable, useful Wave instance that you could install inside a small organization and use for collaboration and communication in a small group. So there's been fantastic progress already from including lots of good contributions from outside of Google already going into Wave in a Box. So I thought we'll start off with an architecture of sort of how that system is going to fit together. And then throughout the next couple of days, there'll be more detailed talks on particular areas of interest inside Wave in a Box and inside sort of the Wave system in general. So this is a very, very high-level view of how a Wave system based on Wave in a Box is going to work. So the Wave in a Box server will be a sort of single-homed instance of a server initially. Our first goals don't include sort of scaling to massive size. We're going to get something working at a small scale first. So your Wave in a Box server will be sitting on a box inside your own firewall, or possibly in any kind of instance hosting environment that you choose to use. On the left-hand side, as you're looking at it there, you can see clients. Clients can connect over the internet or over your intranet. Web clients are, of course, going to be the most common one, and we've just a few weeks ago launched and hooked up the code that does a very rich Wave panel inside Wave in a Box. It's in fact...
Sorry, is it possible to switch this to...
Yes. Goodbye, Dan. We can't see you anymore. Okay. Thanks, Joseph. Right, so just a couple of weeks ago, we hooked up the Wave, the new Wave panel. This was, in fact, code we were planning to launch into Google Wave, and so now we've open sourced it instead. And so there's still a bit of work to go on that. It's missing a couple of the sort of UI features that that Google Wave had, but they're on their way. There's also a console client, which we're going to try very hard to keep working because it's a fantastic debugging tool apart from anything else. And then someone else could write some other kind of client. They're the only two that we're sort of planning right now, but I already know that there's people working on iPhone clients and Android clients and so on. And those connect to the Wave in a Box server via the client server protocol, which there'll be more detail about later on, which runs over a WebSocket or some kind of socket abstraction for. And just as of like a couple of days ago, we can run on browsers without WebSocket now. The console client also connects using WebSocket, and then your Wave in a Box server might offer other client server protocols as well. For example, we have a bunch of servlets that the web client talks to that do things like prefetching of snapshots of data and so on to make it more efficient. But the core protocol will run over something like the WebSocket. Then the server hosts all your waves, and then out the other side, we have other people's Wave servers. And so this is the federation side. So other people's Wave in a Box servers or other Wave servers can communicate with yours over the internet using the Federation protocol running over XMPP. And so, it's our hope that this side of the diagram becomes a huge web of interconnected Wave servers. Oh, by the way, I should have said, if you have a question at any point, stick your hand up and ask. Let's get the questions out early. I will, of course, have question time at the end as well. But in case I'm sort of skipping over something or missing some detail, raise your hand if you have a question and we'll get right into it. Yeah.
Are the slides available? Is there a link to the slides?
The question was, is there a link to the slides? There isn't yet, but we'll copy all of these out into the public. Maybe Pamela can do it now? All right. Pamela will post something to the forum or into the live waves when we have links out there.
Alex, on
Yeah.
the web clients, you mentioned Undercurrent. Are you also still developing Splash, or is that just released as it is?
There's no active work going. The question was, are we still developing Splash? There's no active work happening in Splash at the moment, but we're supporting the API that Splash talks to. So I haven't personally seen it running recently against Wave in a Box, but it should work.
I see it soon. I have a demo.
Leonard has a demo of Splash running against Wave in a Box. Fantastic. So we're planning to maintain it, but there's no active development going into it right now. I guess if someone's really keen about that, that would be a fantastic place to jump in and you could sort of look after that bit of the code for a while. All right. So if we jump inside the server box, this is the logical architecture of the inside of the Wave in a Box server. This is reminiscent of the architecture that the Google Wave system ran at a higher scale, but we've sort of replicated it inside one server. And of course, this opens it up to scaling later on if we decide to split things out in this particular way. So this large box leveled server core here, this is what you might imagine as, that's what we call the Wave server. So the whole thing is the Wave in a Box server, and what we call inside here, its class name is Wave server inside the code. And this is a dumb operation and transform machine. It accepts operations from clients, transforms them against the Wave state, and keeps the history. That's pretty much all it does, although it also has a lot of complexity related to federation and so on. It accepts ops either from its local clients or ops that have already been applied and transformed by some federated server. And so it's responsible for taking those ops, transforming them if necessary, and then sending them back out to anyone who's interested. And anyone who's interested is anyone who's listening on the Wave bus, which is a virtual bus inside the Wave server. All operations which apply to all deltas operations which apply to any wavelet hosted at this server or remotely are pushed out to the Wave bus. And so any software component listening on the Wave bus sees all the Wave traffic and can choose to act on it. So there's no access control or anything happening inside the box. Everything is global. So there's a few Wave bus clients of particular note. Oh, another thing I should point out. Some of what we'll be talking about in this talk and other talks, sometimes we'll talk about how things should be or how we're working towards them being rather than how they necessarily are now. So there's a lot of, the code is more complex than this diagram suggests. We're working towards simplifying it towards this diagram. So I think it's probably best to talk about how we imagine things and the way we talk about things, although sometimes the code doesn't actually reflect that yet. But it's where we're headed. So the first Wave bus client is the client front end, and so this is where the web client hooks up. The web client's WebSocket is coming in from the outside there. So the client front end sits on the Wave bus and receives all the deltas, and then it does access control and has this sort of per user session state to send the right deltas to the right client so that whichever Wave they've got open receives live updates. So a delta comes into the Wave server, is pushed out on the Wave bus, and then the client front end has all the different client endpoints, and it determines which clients have this Wave open and pushes the delta out to those clients. The client front end also receives deltas from all the remote clients, does access control, and then pushes them into the Wave server, submits them to the server core. And then, of course, the server core turns around and echoes it back out on the Wave bus. So that's the client front end. And there's a bunch of servlets implementing various things. The data and robot APIs are one big thing that we have servlets implementing. So these are then not live. So the client front end is looking after sort of live sessions that are held open. The servlets are sort of one-shot requests, typical web servlet. So the data API is not a live session. So these servlets answer the data API, the robot API, which quite often involves submitting deltas to the server core in response to robot operations and the like. There's also a servlet that, question.
Just a quick question. I noticed that with the move to Robot Gateway and to specific servers for specific instances, are we moving away from an agent framework?
What do you mean by agent framework?
When Fed 1 first came out, the idea was to have agents which would then be used to communicate between different parts of your system and the Wave system. But with the robots were meant to be built on top of an agent, but is this going to be a specific task sort of thing as opposed to agents?
Yeah, so the question was, are we moving away from an agent infrastructure, which was sort of first described when we first released the source code, and is in fact the way some things inside Google Wave work? Initially, yes. So the simplest model for Wave in a box, inside one box, is to do this all inside one process. So agents we used to refer to as something that sort of sat on a connection, but it was a system-level service. It could see all the content, and then so you could imagine implementing the robot gateway, which I haven't got to yet, outside of this process, but still on a close, trusted connection to the Wave server. So at the moment, we are implementing all of this inside one box. When it comes time for that kind of scaling, we'll probably investigate something like that. So yes. Okay, then the robot gateway talks to robots. It has a bidirectional communication. It can be called by robots or it calls out to robots. So again, it's kind of the client front end for robots. As deltas are spit out on the Wave bus, it checks if robots are involved, and if robots are involved, it sends events out to robots and then receives their responses, does things, and submits deltas. Leonard will be talking about the robot gateway right after me. That reminds me, is there a clock that I can look at? The clock on the wall there, by the way, doesn't move, so don't look at it. When was I supposed to finish? 10?
No, 10:30.
10:30. Oh, cool.
Yeah, but no.
Sweet. Okay, and then the bottom box here doesn't exist yet. This is one of those examples of things which is how we would like to do it, but it doesn't do it yet. Is indexing. So indexing will be the indexing services will provide things like your inbox search over text, over participants, the same kind of searches you can do inside Google Wave. Provide folders and so on when we have them. So the indexing server sits on the Wave bus and sees everything, and then its job is to maintain an index of what waves are in whose people's inboxes, and then a text index that's searchable. Our initial plans to sort of shortcut this in Wave in a Box were to just cheat and use the data store's built-in text search, whatever it was. But that only does so many things. It becomes very difficult to do that once we have any kind of per-user index state. Like if you archive a Wave, we need to write that to disk somewhere. But it doesn't really belong in the same store where all the Wave data is stored. So indexing, as we start building out that kind of data, well, I guess inbox ends up in a Wave anyway. What's a good example of something the index stores? Well, I guess the indexer will answer the query of what's in your inbox. So for each Wave, we store your state about which blips you've read in a Wave, whether you've put it in a folder or whether you've archived it inside another wavelet inside the same Wave, which we'll describe later. But so the indexer will be responsible for us answering the question of what waves are in my inbox right now. And so as you manipulate the waves, viewing them, and as new waves appear, the indexer will maintain sort of a live view of what your index looks like and what various searches look like. And so it needs to sit on the Wave bus and receive live traffic for that. So they're the major Wave bus components. There'll probably be others cropping up as other services arise. But that gives you an idea of the architecture inside the service. So there's still a bit of crafty code lying around at the moment that we're trying to get rid of. In particular, right now, indexing is not implemented, and there's a bit of a cheat that uses a global Wave to represent people's inboxes. But we're going to get rid of that real soon as we have search implemented. So as soon as we have the data store persisting data, we'll get rid of that. So the data store here, as drawn, only the server core is talking to it, and so this link here is the server storing the deltas on disk as it transforms and applies them. And then the canonical state of a wavelet is simply the deltas that the server has stored to disk. But of course, other components here also talk to data stores. So the attachment servlet, for example, stores attachment data somewhere, and the robot gateway has a list of robots somewhere, and they're all stored in data stores. So this diagram simplifies the data storage story a little bit. But there's those stores are abstracted away behind interfaces in the code, and so they could all, in fact, be different data stores. Any questions so far before I move on from the server box? All right. Any questions on the live wave? Is there anyone watching the live wave? No?
Oh, yeah, thanks for watching. No questions.
Okay.
I see your slides.
Oh, sweet. Thank you. All right. Inside the client, again, this is a very simplified picture of the client and not entirely reflective of how it looks today, but it's where the kind of picture that we're looking towards as a very high-level picture. So the server is off to the right here, and sort of the core flow, the client's job of displaying live waves to you and letting you interact with them, is the top half of this diagram. So the client has some kind of socket connection, a web socket or a flash socket or something like that, back to the server. And that socket is hooked up to what we call the concurrency control stack. It's the communication stack for a single wave. So that looks after performing operational transform for you as operations come in from the server and as you generate operations by typing. The CC stack does operational transform and ensures that your ops are transformed against any ops that you hadn't seen as you were hitting the key, so that all your intention is preserved from all your interactions. And then it presents a live view of the wave. And then the web client hooks this up to what's called a wave stack, which is some code sort of holding this CC stack and it's the current state of the wave in memory. And then on top of that, we have the wave panel. The code name for the new wave panel we released is undercurrent, so you probably see that word throughout the code. The wave panel is responsible for displaying the wave to you on screen, rendering the wave, and certain interactions like marking blips as red when you read them and so on. For each blip inside the wave, there's an editor, and so the editor is a chunk of code we released quite a while ago now. So the wave panel is responsible for hooking up the editor to the code so that when you start typing, the ops spit out of your editor and then back down the CC stack and off to the server after being transformed. And then, of course, you can, I guess you can't yet in Wave in a Box, but you can have multiple waves open in theory. This whole stack is a per wave thing. And then we also have a bunch of servlets. So front ends. Oh, that's not a very good diagram. Front ends to the servlets, and so the wave stack uses the prefetch servlet to fetch efficient snapshots that can be cached by the browser and so on, rather than pumping them over the WebSocket. So it'll use this to sort of fetch snapshots, but then there's a bunch of other servlets. Again, the attachment upload servlet being a good example. We'll use the data API for search soon. So here the digest panel. The digest panel is the left-hand panel in Wave. It shows at the moment your list of waves. But as we begin implementing search and things like that, it'll show search results. So that will talk to some servlet providing the search results via the data API's search functionality. And then a few grayed out boxes over to the right of client components that don't exist yet. Contact management is something we haven't attempted to implement yet. And folders and other sort of wave management tasks, folders and saved searches and so on, we also haven't implemented. Will be separate client components talking to some kind of servlets to be live. So it's a very simplistic overview of the client, but will help you hopefully understand what's happening if you go delving into the code. Are there any questions about anything so far? All right, well, that's all I had. Makes it sound really simple, really. Yes?
What's the primary data components that are sort of flowing over the wave bus? Is that the deltas, operations, or what other information is flowing?
Yeah, sure. So the question was, what's the information that's flowing over the wave bus? The wave bus is deltas, and so a delta is a container with a bunch of operations, operation being sort of an atomic mutation on the wave, and the delta bundles them up with some metadata like the author of the operations, the timestamp they were applied, and so on. So deltas are submitted by clients and processed by the server core, and then deltas come back out on the wave bus. Deltas are also what flows over the client-server protocol. The client front end basically just does some filtering and pushes those same deltas back out over the client-server protocol. There's also means to fetch the snapshot state of a wave. We don't really think of that as going over the wave bus, but it follows the same path.
Is there any kind of a distinction between incoming delta from the client and a delta that's produced by the core, and maybe one being more authoritative than the other, or what's the cost?
Yeah, so there is. We only recently introduced this distinction sort of in the code. So if you're looking at the code inside the server now, there's two different classes, one representing a delta as submitted by the client, and it lacks information like the timestamp, which is chosen by the server, and a signature, which the server computes. and then the class name called transformed wavelet delta represents something that's come back out of the server and has authoritative metadata associated with it. On the wire, the protocol doesn't yet quite capture this distinction, but we're working towards that.
I'm going to touch tomorrow in the Wave server.
Do you want to just talk at the mic so the stream and so it's recorded properly?
Tomorrow morning in the Wave server talk, I'll go over the Wave bus again and be more specific about the interface. I think so at the level of these diagrams, it's useful so there are these two classes called Wave bus and Wave provider. I think it's useful to think of both the subscription where you get the deltas and also something called commitment notices to learn when things have been persisted. Is running out, is broadcast on the Wave bus, and then you can make sort of RPCs or procedure calls from these clients of the Wave bus to the Wave server to request operation delta history, to provide help to request snapshots, and to submit deltas.
Thanks, sorry. Question?
There's been a mention of snapshot record or Wave snapshots as the optimization. Can you 1 minute description of what they are?
Sure. The question was, what's a Wave snapshot and how are they useful? So a snapshot. Well, let's start with delta. So the history of a wave is purely defined by its deltas. If you threw away all other data and just had deltas, you would still not have lost anything. Everything else is computed. A snapshot is simply the result of applying some initial sequence of these deltas to an empty wave state, and so the deltas mutate this state to reach some state like what you would, like an initial state you get when you open a wave in the client. That's a snapshot at some version of the wave, or a rendering of. So a snapshot is just the resulting state from applying a bunch of deltas from the start of the wave, and so they're useful because that's normally much more of a concise representation than the delta history. And so a snapshot is what we fetch over the client-server protocol when we're first going to show you a wave. We ask the server to compute a snapshot of the current version, and then the client just sort of directly renders that. Inside the Wave server, they're also useful. So the robot operations that robots apply are normally against some, we fetch a snapshot of the wave and then mutate it according to what the robot asked us to do, and then the deltas that result from that mutation we submit to the core. Does that answer the question?
Yeah, well, is there any intent to persist snapshots?
Is there any intent to persist snapshots? So they're redundant in that the deltas provide all the information you need. We probably will end up persisting snapshots periodically, again, as an efficiency gain, so that when someone asks for a particular snapshot, we can just read one off disk instead of recomputing the whole thing. We'll probably store the latest version snapshot. Whenever we sort of write a bunch of data to disk, we'll store a snapshot of that point as well. Any other questions? All right. Well, I finished nice and early. So the next talk is Leonard talking about the robot gateway, and I guess let's start right away, and then we can slightly have a longer break after Leonard's talk is done. All right. Fantastic.